All right, today we're going to be talking about Chapter 5, Lesson 5. It's called Simplifying Algebraic Expressions. So as we go through this and identifying parts, there are a couple different parts of an expression that we can identify. So each time we have something that's separated by a plus sign, or in some cases a minus sign, those are terms. And we talked about that with our algebra tile activity. But the three terms then in this expression would be negative 4x, 12, and x. Because those three are separated by a plus sign or a minus sign. And in this case, specifically, it's a plus sign. Now, when it comes to coming up with like terms are terms that have the exact same variable to the same power. That would be negative 4x and x. They both have an x. They're both raised to the same exponent. In fact, there isn't one here, which means it's 1. So our like terms would be negative 4x and x. Coefficients are going to be numbers that are attached to variables. In that case, right here, we have a negative 4. And really, right here, there is a number that doesn't show up. But we say that there's really a 1 there because I have 1x. So the other coefficient is 1. And then a constant would be terms, or a term that doesn't have a variable attached to it. So that would simply be 12. All right, let's look at example 1 here where I identify parts of 3x minus 5 plus 2x minus x. Now, the terms in this case, we have 3x, we have 2x. Now, right here, this is not simply going to be just a 5 because we want to always have addition signs between our terms. So if it's a minus 5x, that really means we're adding a negative 5x. So this would be negative 5. And over here we're adding a negative x, so this would be negative x. Now, our like terms, we can look simply in our terms section here and find the ones that have the same variables raised to the same exponent. That happens to be these three right here. So it'll be 3x, 2x, negative x. Coefficients, these are the numbers that are attached to variables. Again, so that would be a 3. That'd be a 2. And right here, there's really a number. It's a negative 1. And then the last part here, a constant, that's a number that has no variable. That would be negative 5. Now, as we go through this, like terms, like these three in this case, or up here we'd have negative 4x and x in this case, we can actually combine those together. Because it's like we have two piles of the same thing. We can combine them together to make one pile. So let's go ahead and show how to do this. If we look at example 2, writing 4y plus y in simplest form, we can actually combine those together. So we have a 4y and a y. When we do that, we add the coefficients together. So in this case, it'd be 4. And really, there's a 1 here. So we combine those to be 5. And then we simply put the variable at the end. So this is 5y. And that makes sense. If I have 4 of something and 1 of the same thing, I can combine them to make 5 of that same thing. Example 3, write 7x minus 2 minus 7x plus 6 in simplest form. It should be in, not is. In, not is. So as I go through this, I want to identify my like terms. So my like terms, I'm going to do my variable terms as one color here. So that'll be 7x and negative 7x. Those are like terms because they have the same variable raised to the same exponent. And then I also have these as like terms because those don't have a variable. So when I simplify, I can combine like terms. So I have a 7x and a minus 7x. And then I have a minus 2 plus 6. 7x minus 7x, this creates a 0 pair. So that means that's gone. And negative 2 plus 6, I'm adding numbers that have opposite signs, so I subtract them. Keep the sign of the number that's farther from 0. So 6 minus 2 is 4. 6 is farther from 0 than negative 2. So this simplified down would be positive 4. And that seems like a lot of stuff just to get down to this, but that's why we simplify, so we don't have all of this here. Because this all simplifies down to 4. So why have all this extra stuff? All right, last example here. This is a word problem. This is going to bring us right back to our percents chapter. But it says the cost of a set of DVDs after a 25% markup can be represented by the expression C plus 0.25C. And that makes sense. That was one of the methods that we could use in order to find a total price. So it says simplify and determine the cost of the DVDs after the original price is $40. So the first step I want to do is simplify. We have like terms. Both of these terms has a variable, exactly the same variable, with exactly the same exponent. They're both 1 in this case. So I can add the coefficients. Now, really, there's a coefficient of 1 here. So I can do 1 plus 0.25. And that will get me 1.25. So the simplified version of this expression is 1.25C. Now, the question is really asking now, find the total cost if the original price is 40. Now, this original price would be C. So I'm going to solve 1.25C if C equals 40. Which means I'm going to substitute 40 in for C. So I have 1.25 times 40. And if I do that, that means it would be $50. So the total cost after a 25% markup on $40 is $50. So the DVDs will cost $50. All right, that is the end of Lesson 5. If you have any questions, please let me know.